Hello students, this is Mr. Lesage again, and this lesson is from Math 7.2, Scale Drawings and Area. Here are the three kinds of problems that you're going to encounter. Actually, there's really two kinds of problems, but they come in enlargement and reduction types. So we're going to look at three of those just so you get an idea what to do. In the first question here, we have this large piece of carpet that's 8 feet wide and 12 feet long, so 8 by 12, and it needs to be reduced by a scale factor so that the reduced carpet is only 2 feet wide. So the original carpet was 8, the new carpet is 2, so that is going to be this fraction, 8 divided by 2, or 8 over 2, which means we've reduced it by a factor of 4. So, if the length was 12, and we want to reduce it by a factor of 4, then we would have to take the 12 and use the factor of 4 on it, and that means that the length now would be 3. So remember, we had a width of 2, a length of 3. It asks us what the new area of this carpet should be, so 2 times 3 is going to be our answer, or 6 square feet. So you can see how we create ratios, as we always do for scale models, and solve this problem. Here's a problem that we go the other direction, where we're enlarging something. So we start out with a garden that is 1.5 feet wide and 4 feet long. It says we are going to enlarge it by a scale factor of 7. So when we're enlarging, the mathematical operation that represents enlargement is not division, it's multiplication this time. So we're going to take our two measurements, the width and the length, and we're going to multiply it by the scale factor. So we're going to start out with the width, which was 1.5, and we're going to use our scale factor of 7, and that gives us a 10.5 foot long width. Now we're going to take the 4 feet, which is the length, we're going to multiply it by the same scale factor, and we'll get 28 for the length. Now remember, the width was 10.5, so we're going to multiply our length and width, which means 28 times 10.5, and that will give us 294 square feet for our new total. All right, the last problem looks like this, and what the question asks in this one, I cut the question off, sorry, but a rectangle is enlarged by a factor of 6. This is the original, and because it's square inches, we know that they're showing us the area of the little rectangle. We're enlarging it by a factor of 6. Now, a lot of times, they'll ask us for the area of this new one, and a lot of students will say, well, if it was enlarged by a factor of 6, then 6 times 20 should give us the answer. But that's not how enlargement works. If we're enlarging this rectangle by a factor of 6, that means this width is being multiplied by 6, and this length is being multiplied by 6. Area is multiplying length and width together, so we would be multiplying 6 times for the width and 6 times for the length, and we would be getting 36 times larger area because of that. Well, if the original area was 20, and our scale factor is now making it be 36 times bigger, then we would just multiply those two together, and our new area would have to be 720 square inches. I hope that helps your understanding of the scale factor and how it affects areas. And that's all for this lesson. Good luck.